everyone, let us solve some more problems on bivariate probability. Let us solve the first problem. X is a random variable which is uniformly distributed between plus or minus 1. Two independent realizations of x are added to obtain the new random variable y, that is y is equal to x1 plus x2. What is the PDF for y? Let us plot the PDF for x1 and x2. They are as shown in these two figures. PDF for f(x) of x for a uniformly distributed random variable is equal to 1 divided by b minus a, that is 1 divided by b is equal to 1, a is equal to minus 1. So it is 1 by 2. In order to find the PDF for y, we need to convolve fx1 with fx2. To do that, let us take the negative of fx2, then let us shift over the axis y. So we get y minus fx2. Now let us scroll this over this from minus infinity towards plus infinity. Let us take the first interval. Then y plus 1, then I am going to move this over this y plus 1 comes and falls at minus 1. That is y less than minus 2. So there is absolutely no overlap. Therefore, the PDF for y is equal to 0. At the end of the first interval, y plus 1 was at minus 1. Now we move further till y plus 1 reaches 1. That will give us the second interval, y plus 1 equal to 1, y will be less than 0. The overlap is going to be minus 1 to y plus 1. Let us try to find the PDF for y. We will try to integrate the product of two periods with respect to x over the period minus 1 to y plus 1. That will give you 1 plus 1 by 4 y plus 2, y value varying between minus 2 to 0. At the end of the second interval, y plus 1 was at 1. Further movement till y minus 1 is going to reach 1. Will give us the third interval, y minus 1 equal to 1, y less than 2, overlap is y minus 1 to 1. So we will try to find the PDF for y. That will be by integrating the product of the two periods with respect to x over the period y minus 1 to 1. We get that as 1 by 4 2 minus y for the period interval of y between 0 to 2. Fourth interval, we know that a further movement of y minus 1 greater than 1, that is y greater than 2, there is no overlap. Therefore, the PDF fy of y is equal to 0. Let us take the second problem. X is a random variable uniformly distributed between 0 and 3. Y is a random variable independent of x, uniformly distributed between 2 and minus 2. And the new random value w is obtained by adding these two random variables x and y. Therefore, w is equal to x plus y. What is the PDF for w? Let us draw the PDF for x as shown here, and this is the PDF for y as shown here. PDF for x is equal to 1 by 3. PDF for y is equal to 1 by 4. Now, in order to obtain the PDF for w, we need to convolve y over x. So let us try to move this over this. So first interval will be w plus 2 should be less than 0. I am scrolling this over this till w plus 2 is less than 0. So which gives me w less than minus 2. There is no overlap. Therefore, the PDF for w, fw of w is equal to 0. At the end of the first interval, w plus 2 was at 0. Let us scroll this fy of w minus y over fx further till w plus 2 reaches 3. So w second interval will be w plus 2 is equal to 3, w less than 1, overlap period is going to be 0 to w plus 2. Let us compute fw of w by integrating the product of two PDFs with respect to y and over the overlap period 0 to w plus 2. So we get the answer as 1 by 12 w plus 2 for the interval w varying between minus 2 to 1. At the end of the second interval, w plus 2 was at 3. We'll move it further till this w minus 2 reaches 0. So therefore, w is less than 2 in the case of third interval and the overlap period is 0 to 3. Fw of w is the integration of product of two periods with respect to y over the period 0 to 3. We get the answer as 1 by 4 for w varying between 1 to 2. At the end of the third interval, w minus 2 was at 0. We move it further to obtain the fourth interval till w minus 2 reaches 3. So therefore, w is less than 5. Overlap period is going to be w minus 2 to 3. The PDF w of w can be obtained by integrating the product of two PDFs with respect to y over the overlap period w minus 2 to 3. We get it as 1 over 12 5 minus w for all values of w between 2 to 5. The last interval, fifth interval, w minus 2 is greater than 3. That means w is greater than 5. There is absolutely no overlap. Therefore, the PDF SW of W is equal to 0. We take the third problem. The random variable u is uniformly distributed between plus or minus 5 and the PDF for random variable v is defined as 3 e to the power minus 3v u of v. U and V are independent and W is equal to U plus V. What is the PDF for W? So this U is uniformly distributed between minus 5 to 5, whereas the PDF for V is given as 3 e to the power minus 3V U of V, that is plotted here. And the PDF for u is given by 1 over 10. We need to convolve this with this. So let us take the first interval. When we convolve, we'll try to scroll this over this till w reaches minus 5. Its fw of w will be 0 because there is no overlap. In the next interval, we are moving this further till w reaches 5. So that time we can get fw of w is the product of these into PDF, and we are going to integrate this with respect to c. We get the answer as 1 over 10, 1 minus e to the power minus 3 w plus 5. That w value is varying between minus 5 to 5. Further movement of this over this will be beyond this w moving beyond this 5. So therefore, the overlap period is going to be minus 5 to 5. So let us integrate the product with respect to v between the overlap period minus 5 to 5. That will give us 1 over 10 e to the power minus 3 w minus 5 minus e to the power minus 3 w plus 5 for all the values of w greater than 5. Let us begin the fourth problem. The random variable x has the PG of 3 into 7 minus x for all values of x varying between 0 to 7 and is 0 otherwise. The random variable y is independent of x and is uniformly distributed between 0 and 1. We have a third random variable w, which is the sum of two random variables x and y. We need to find the necessary value of c and then find fw of w. Periods for fx of x is given, that is c into 7 minus x, and y is uniformly distributed, therefore fy of y is equal to 1 divided by 7. Since x and y are independent variables, we know that fx of x into fy of y is equal to bivariate periods fxy x comma y, that is equal to 3 into 7 minus x into 1 by 7. So let us integrate this bivariate periods with respect to x1, second time with respect to y, and let us equate it to 1. So from using this formula, we can obtain the value of c, that works out to be c equal to 2 divided by 49. Let us consider the first integral w varying between 0 to 7. Fw of w is equal to integral of 0 to w 2 divided by 49 7 minus w plus tau divided by 7 d tau. By integrating this, we get the answer as 2 divided by 343 into 7 minus w whole square by 2. Second integral, w value varies between 7 to 14. Overlap is w minus 7 is 7. Fw of w is the integral of w minus 7 to 7, 2 divided by 49, 7 minus tau divided by 7 d tau. We get the answer as 1 divided by 343 w square minus 28w plus 196. Thank you. In the next video, let us solve some more problems on bivariate PDF.